Welcome everyone, my name is Jeremy Faludi and this is a lecture on laws and labels for sustainable design for the Minneapolis College of Art and Design class, Collaborative Product Design. So environmental laws and environmental labels are actually quite similar. The main difference is just that laws are mandatory and labels are optional. They can have very similar structures and incentive systems, and they can move industries to similar degrees sometimes. So first, when we talk about laws, we're going to talk about the big three laws for most products. These are sort of the most significant environmental laws out there in the world right now. They all happen to be from the EU, but many countries in Asia are implementing them as well, and some states in the US are also doing their own versions, or may in the future. And we're going to talk about different kinds of laws, so how laws are structured and how that affects basically the marketplace, and what strategies for designing good laws might be, so that if someday you are designing policy or advising others on policy, you'll at least have some sort of introduction of what to think about. Then the next part we'll be talking about eco-labels. I'll mention some popular labels today and some features of labels or marketing claims, as well as strategies for designing good labels. The first of the big three laws we're going to talk about is reduction of hazardous substances, and this is a pretty straightforward one. It basically just sets maximum concentrations that you can have in a product of these various hazardous substances. And this is mostly related to electronics, though it could apply to other fields as well. Yeah, it's mostly electronics, and so the limitations are set on cadmium, mercury, hexavalent chromium, polybrominated biphenyls, PBBs, and polybrominated diphenyl ethers, PBDEs. Both of those are basically flame retardants. That's what they're generally used for, and lead. And so these things appear in the plastics of cases, or where some of the flame retardants will show up. In circuit boards is where the lead and cadmium and mercury will show up, like lead in solder, for instance. Mercury can show up in fluorescent lamps. Cadmium can show up in plastics as well. Probably the most significant war story here is back in 2006 or 2007, the Sony PlayStation that was shipping to Europe at the time was over the cadmium limit in the power cord, not even in the device itself, not in the PlayStation itself, just in the power cord. The cadmium was it's usually used as a stabilizer or colorant in some plastics. And because this PlayStation was over the limit, the Netherlands banned it, and this happened just before the Christmas rush, which is sort of when everybody buys these things, and the company lost $100 million. So this can be a significant deal here. And one useful thing about the implementation of this law is that the government can receive information about potential violators of the law from anyone. So a company could tip off the government that its competitors are violating this law. Companies could watchdog each other. It doesn't require the government itself to have a huge staff of people that are doing the investigation and enforcement, although it certainly does have some staff to do that. So that's the first one. The second one is WEEE, which is just fun to say. It's the Waste Electrical and Electronic Equipment Directive, and this is basically extended producer responsibility. So it means that manufacturers have to take responsibility for the products at the end of their life. That doesn't necessarily mean that the companies themselves, that the manufacturers themselves have to do the recycling of the products, but they are responsible for it. So if they're not going to do it themselves, they have to make sure there are other companies that will do it and that they will handle the financial implications of that. Now, the EU has found that has not actually been as effective as they'd like. They've found that only about a third of electrical and electronic waste in the EU is reported as separately collected and appropriately treated. And they're trying to recast the law to set mandatory collection targets of more like 65%. So we'll see how that goes. But it has already created a difference in the industry. So the third big law, also from the EU, is REACH. This is the Registration, Evaluation, and Authorization of Chemicals Act. And basically what it means is it is shifting the burden of proof for the toxicity of chemicals, so that rather than chemicals being innocent until proven guilty, they are basically guilty until proven innocent. So if you are a company and you are creating a new chemical that's going to be in products, you have to prove that it's safe, rather than companies being able to produce whatever chemicals they like, and then the government being the one responsible for finding which ones are toxic, because that can be an extremely expensive and time-consuming endeavor, particularly when there are gray areas where it's not quite clear how toxic something may or may not be. Things can get wrapped up in courtrooms for literally decades. So to have the burden of proof on the companies saves governments an enormous amount of money and time and keeps people much safer. So the way that REACH works is that all chemicals that are produced in the EU or that are imported into the EU in quantities more than 1 metric ton have to be registered in the REACH database system, basically. And to be registered, they need a material safety data sheet, that's an MSDS, and they need risk management guidelines, and they need safety measures for downstream users. And this paperwork, or digital information, has to include all usage scenarios that that chemical is sold under. So it requires communication up and down the supply chain. So for instance, if a company manufactures additives for plastics that are, maybe they make them more flexible or UV resistant or flame retardant or something, it can't just shove the responsibility off on the manufacturer that put their chemical in their plastics by saying, oh, that company didn't use it properly, because if they used it properly, then they have it registered for that use in that application. And so there's accountability up and down the supply chain here. So there's about 1,500 chemicals that are also specifically listed as hazardous chemicals under the Act that require permission. These are existing chemicals, and they will be authorized as resources allow. So again, the financial structure of this is much better, so that the government obviously has a limited amount of money and a limited amount of time, and they will approve what they have time and money for, rather than letting everything go and only stopping what they have time and money for. So it's a much more consumer-friendly law in that respect. That is just much more financially viable. And perhaps the most powerful thing about this is not just the fact that these chemicals will require authorization, but this database that all this information is going into will be at least partly public in its availability. So consumers and watchdog organizations, nonprofits, can request chemical toxicity data. So consumers and consumer watchdog agencies, various nonprofits or the like, can request chemical toxicity data. And that means that, again, the government does not necessarily need to be the one with the funding and the time and the people power to investigate all these things, that anybody out there in the world can be investigating these things, and so that can make it a much more effective legislation. So just as one example here, if a manufacturer of blue jeans uses a dye to make them blue, and they have 1 gram of dye in every pair of jeans, but they sell 1,000,000 pairs of jeans, that's more than 1 ton. And so that dye chemical needs to be registered. Okay, so that was the sort of big 3 in environmental legislation. And now, what if you were creating a law, or what if you were advising people on creating policies? What are the different kinds of laws, and how do they act? What incentive structures do they create? Well, basically, there's 3 different kinds of structures. There's thresholds, taxes or rebates or feebates, and cap and trade. And then finally, there's prescriptive laws versus performative laws. So with thresholds, these are a simple yes or no. So for instance, reduction of hazardous substances, that just says, no, you cannot have more than, say, 1,000 parts per million of lead in your electronics product. And these are static. You know, that limit is not changing. It's set. And these are good for zero tolerance conditions. It's a prescriptive law, meaning that it's telling you what to do or not do. And so there's one possible concern here, which is that you might substitute some other material that actually is more toxic. And this is one of the advantages of performative legislation rather than prescriptive legislation, although it's difficult to do performative legislation versus prescriptive legislation when you're talking about toxics, just because it's more difficult to measure the toxicity of different chemicals than it is to, say, measure the kilograms of CO2 being emitted. So another problem of thresholds is that enforcement is generally costly. So there's no revenue being generated by this yes-no threshold, so the government needs to have funding from elsewhere to fund the enforcement and the investigation of this.